Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. Today we want to go further in completing the square method. And we understood that we can solve quadratic equation by completing the square, and we specifically highlighted perfect squares, and we gave an example of a perfect square as in x plus 2 can be written as x plus 2 squared. That is exactly what we said. But today we want to learn how to write x squared plus bx plus c in a quadratic equation, rather in the form x plus p, and you can see this part is a perfect square, plus q. Whatever remains outside the perfect square and is a constant is called q, and we're going to see how to have a perfect square. This is the part of the perfect square. And I want, as we begin the journey very slowly, and if you compare x squared plus bx plus c to be exactly equals to x plus p squared plus q, and call this equation 1, we may want to expand the right hand side, and have x plus p multiplied by x plus p, of course, plus q, which will come later. This is going to be x squared plus xp plus xp plus p squared. Now this is an expansion of this bracket, so we still have plus q. And this one definitely gives us x squared plus 2xp plus p squared plus q. This is what we are saying it equals to x squared plus bx plus c equals to that. At that point, we would wish to talk about comparing terms. Comparing terms. We can say anything that has to do with x squared is equals to anything that has to do with x squared. So on the left hand side, comparing terms, on both sides, comparing terms on both sides. So we can say this x squared is exactly equals to x squared, and there's no problem with that. But this term that is carrying x is going to be bx is going to be 2px, this term, because it's the one that is having x and this one is having x. So from here we can already see that if we divide by 2x on both sides, we would wish to make p the subject of the formula. And from here you can see, if we talk about 2px is equals to bx, if we divide by x and by x, that one goes away, and we'll be left with a situation which tells us that 2p is equals to b. And then at that particular point, we can divide by 2 and by 2, and we can easily see that p is equals to b over 2. And you can see where our p is situated. You can see where our p is going to be b over 2. And if you look at the constant c is equals to all of these constants c, and therefore if we extend further, we're going to have this part of the constants, and we're going to call it p squared plus q is equals to c. And but we know p is equals to b over 2. So if you want to make probably q the subject of the formula here, we're going to have q is equals to minus p squared plus c, because this one just crosses over to be subtracted. And in this case, because we know the value of p, which is b over 2, then q easily becomes minus b over 2 squared, because that is what is p squared. Of course, plus c. Whatever c was originally, it comes here comfortably. So we would wish to just generalize this and have x squared plus bx plus c is equals to x plus p, which is b over 2, which is p b over 2 squared, plus q, which is minus b over 2 squared plus c, which is plus minus b over 2 squared plus c. So generally what we are having is x squared plus bx plus c is equals to x plus b over 2 squared minus b over 2 squared, because plus followed by a minus is a minus, plus c. And this one is just going to be observed in example 5. So if we wish to talk about example 5, we are told to write this quadratic in the form, write x squared, or rather write x squared plus 4x plus 5 in the form x plus p squared plus q. And it goes without saying, we know x squared plus 4x plus 5. In this case, you can already see our b. If you compare this with the general equation of ax squared plus bx plus c, you can already see that our a is 1, it's just 1 there. Our b is 4, you can see 4, and our c is 5. So this one, if you want to write it in the form of, in this form, we're going to have x plus p. But what is p? b over 2. X plus 4 over 2 squared minus minus, because we're going to talk about p squared, 4 over 2, that is b over 2 squared, plus c, which is 5. And at the end of the day, what we are having here is something that looks like x plus 4 over 2 is 2 squared, minus 4 over 2 squared is 2 squared, which is 4, plus 5. And at the end of the day, if we collect these like terms, we are having x plus 2 squared plus 1. And this is exactly what we have had. So if you consider this one to be in terms of x plus p squared plus q, then we can easily say that p is equals to 2, you can see it here, and q is equals to 1. Yes, we have been able to write x squared plus 4x plus 5 is exactly equals to x plus 2 squared plus 1. And that is just like it. We have been able to complete the square so easily and very comfortably. So again, visit my YouTube channel. Please subscribe and share widely, and let us work together. All right.